The biggest bottleneck in global communication today isn't that AI models aren't smart enough. It's actually our fault. We are forcing brilliant AI to play a blindfolded guessing game, and then we spend millions of dollars cleaning up the mess. If you're operating in localization and translation, you already know this is a long game, but the rules are fundamentally changing. This is Locanucu, localization news you can use. The language industry is experiencing a fundamental architectural shift. We are looking at the critical transformation of the human in the loop. For anyone managing global content, we really have to shift our mindset away from this exhausting routine of just fixing AI mistakes after the fact. The real bottleneck is how we design systems that behave predictably at scale. For years, the localization industry has relied heavily on a standard paradigm. The whole industry was super comfortable living in this purely reactive linear assembly line. You let neural machine translation, or NMT, handle the bulk of the transformative work, churning through thousands of words, and humans were brought in at the very end to fix the errors. From an economic standpoint, a decade ago, this post-editing approach made perfect sense for predictable content and highly repetitive scenarios like massive software manuals. It was the most logical way to use NMT, reducing the overall effort, and then subsequently using that corrected data to train the engine further. But this legacy loop keeps language professionals trapped in a strictly corrective position, constantly looking backward. But the landscape of communication is changing rapidly. You aren't just translating sterile, static instructions anymore. When dealing with genuinely new examples, shifting terminology, or novel communication intents, models lack the prior information needed to succeed. Expecting a human to fix all of that nuance at the end of the pipeline is like hiring a master architect, giving them a pile of raw lumber without a blueprint, and getting mad when they build a rustic cabin instead of the modern luxury home you secretly wanted. To understand why they build the wrong thing, you have to look at the underlying mechanics. At their core, large language models act as next token predictors. For those navigating different subfields, a next token predictor simply means the AI calculates the mathematical probability of what the next word should be based on what came before it. It's basically autocomplete on your phone, but on steroids. If you type, "I need a hot cup of," your phone guesses coffee because statistically, out on the internet, that is a highly common phrase. It doesn't actually know you are a strict tea drinker unless you explicitly program that rule beforehand. Because these models operate this way, an underspecified prompt forces the model to guess based on its training data priors. These guesses are often structurally predictable and beautifully fluent, but they are still completely wrong for the specific context of the user or the brand. You end up with a fluent hallucination, which is exactly why the industry requires a new type of role. Instead of just cleaning up after a machine, linguists must become designers and curators of language assets. The work is shifting toward curating the exact terminology sets needed for hyper-personalization or an intentional brand voice. Here's the interesting part. Consider a scenario where a company wants to target multiple regional variants of a language. In the past, creating personalized pipelines for every single demographic was prohibitively difficult and slow. The people and pipelines required simply did not exist at scale. But today, with modern models, generating hyper-personalized content can be as simple as flipping a switch to reference a different set of terminology and style rules. You want to target teenage esports fans in Brazil? You just switch the active asset, and the model suddenly prioritizes gaming slang. You want to target financial analysts in Frankfurt? You switch the asset again. The heavy lifting is no longer in the post-editing phase. The real work, the true linguistic intelligence, lies in designing the assets that feed the machine in the first place. This transition elevates the language professional, moving away from asking why a term was applied incorrectly during review, and instead empowering a language designer to intentionally curate options before the content is ever generated. But this brings up a massive operational challenge. If you are moving your linguists away from fixing the final product, their deep expertise needs to be injected much earlier. The traditional human-in-the-loop model places the human in a fundamentally reactive position. The AI performs a task, and the human comes in afterward to correct it. While this theoretically provides feedback signals, this loop is incredibly slow and structurally flawed. This is where it gets tricky. When a language professional makes a correction to an output, they are triangulating a massive amount of contextual information. They understand the coherence required across documents, the named entity constraints, and the specific intent of the message. They know exactly why a word needs to change. The machine, however, only sees the surface edit. It only registers what changed, not the intricate reasoning behind the change. Because the machine lacks this critical context, the amount that the system can actually self-improve is severely limited. It is not getting smarter at the pace of the intelligence of the human. You can feed it 1,000,000 corrected surface edits, but if you haven't taught it the architectural rule, you are just putting band-aids on a leaking pipe. To build a predictable and scalable language system, we must move the human to be in control of the loop. This means governing how the system works from the ground up. Placing the human in control means stopping the harmful practice of sending single-segment files floating around without context. When a linguist receives an isolated segment, they are supposed to magically guess what the author intended. Imagine sending your translation pipeline the isolated English phrase, "serve the board." Just those 3 words floating in a vacuum. Are we talking about a waiter delivering an artisan cheese platter in a restaurant? Or are we talking about an executive presenting financial data to a board of directors? Those require entirely different grammatical structures globally. This task framing creates opportunities where someone has to fill in a guess, and when that guess is wrong, it is a completely predictable failure of the system, not a failure of the linguist or the model. Controlling the loop requires building an environment where language intelligence is injected at the core of the process. By providing robust assets and steering the generation process, the human uses the machine to produce exactly what they intended to produce. This ensures that the model has all the necessary information to succeed before it predicts its very first word. For far too long, our industry workflows have kept linguists in a corrective posture. The next major wave of investments in language architecture must focus on giving linguists the tools to actively steer and guide translation. And this is where you have to understand the core difference between legacy tech and modern tools. Large language models operate very differently than traditional NMT systems. With NMT, custom training often involved feeding post-editing data back into the system to reward alignment with prior outputs. You were essentially constraining the model, decreasing its overall capability to force it to match a specific established pattern. You had to put blinders on it. LLMs do not necessarily require this trade-off. They are capable of generating a wide variety of answers, styles, and vocabularies without losing their baseline capabilities. You do not have to decrease capability in favor of alignment, but to get the right output, you must be highly specific about what you want. Specificity is the new superpower. If you do not supply preferred terminology or specific style rules, the model will simply fall back on its defaults, and these defaults are rarely what an enterprise actually wants. Steering models require structured, queryable insights. Think about language structures that do not map perfectly from one language to another. Let's look at capturing intent with a phrase as common as "consult the lawyer." In an English source text, that phrase does not specify any gender. But if the target language requires a masculine or feminine designation, like Spanish, the English source text has failed to provide that crucial specification. Because the model is a next token predictor, it is forced into a position where it must guess. By hooking up linguistic assets properly upstream, we can capture that intent and structural necessity at the time the content is generated. We transform static assets like term bases, translation memories, and style guides into queryable, machine-usable communication tools. Think of an API intercepting the text, querying a structured database, and pulling the specific rule that says, "use the feminine noun here," packaging it straight to the model. When these assets are available to the model at the exact moment of generation, we stop treating localization as an afterthought. We can structure phrases in ways that avoid ambiguity. And here's the upside. Almost always, The improvements that make a source text translate better also make it better in the original language, as it removes awkwardness and ambiguity. We steer the translation to be what it should be, fundamentally improving both the source authoring and the multilingual targets simultaneously. Achieving this new architectural standard is not something a standard machine learning team can do alone. Yes, the baseline fluency of multilingual generation has certainly improved tremendously. However, the exact precision, brand adherence, and cultural nuance that enterprises demand require a level of linguistic knowledge that ML operations engineers simply do not possess. Building these systems requires a deep, integrated partnership between linguistic experts and technical engineering teams. Currently, the standard paradigm for improving translation systems is heavily dependent on slow engineering cycles. The collection of data, fine-tuning, QA, and release form an inherently long loop. If a linguistic team needs an adjustment made to the system logic today, it goes on to a development sprint list and might take 6 to 12 months to be resolved. This slow cycle cannot keep up with the agile nature of modern communication. The solution is to design language assets that are portable, inspectable, and modifiable directly by the people who understand language. If we change our system interfaces, we can empower language professionals to adjust terminology, refine style rules, and steer the AI without needing to ask an engineer. We can make systems that are hyper-responsive. This partnership ensures that engineering investments are focused on creating a durable, improvable system architecture. The industry currently faces a massive risk where companies are heavily investing in prompt tricks or pipelines designed to accommodate a specific model. Chasing prompt tricks is a strategic dead end. When the next, more advanced model is released, those localized investments get wiped out because the new model does not require those specific workarounds. By focusing on durable language assets and flexible system interfaces, engineering and linguistics can co-evolve. When language designers can manipulate the system parameters themselves, the entire localization workflow becomes incredibly responsive, scalable, and tailored to immediate business needs, ensuring that investments yield compounding benefits over time. Before we get into the final takeaways, just a reminder that you can find more insights and architectural strategies like this at Locanucu.com, your home for localization foresight. Now let's lock in the actionable insights you need to take back to your teams. The language industry is moving upstream. We are transitioning from a slow, after-the-fact transformation process into an era of proactive, multilingual generation. What we are seeing is that AI models are incredibly capable, but they require the correct structural environment to thrive. Your mandate is to shift the human role from reactive post-editor to proactive language designer. You must take definitive control of the feedback loop and actively steer your models with active, queryable assets instead of flat glossaries. And crucially, you have to foster a true integrated partnership between your engineering teams and your linguistic experts. This agile, architecture-first approach is the only way to deliver the precision, speed, and hyper-personalization required in the modern localization landscape. If we build perfectly structured systems where the machine never has to guess our intent, that rigorous demand for clarity might just change how we speak to each other natively. And this was your industry update from Locanucu, localization news you can use. The biggest takeaway today is that you must stop spending your budget cleaning up AI mistakes at the end of the line and start engineering the upstream intelligence that ensures the model gets it right on the very first word. We'll catch you next time.